Alright, so today we're going to talk about factoring complex trinomials. This is a bit of a complex lesson, so I'm going to really encourage you to pause when you're not quite getting something, rewind it, watch this video as many times as you need to, okay? So we're going to start off with a bit of definitions and a bit of discussion here. Complex trinomial, just so that we can define it, is not a simple trinomial because of that number in front, being that lead coefficient is not a common factor. So we can't common factor the 3 out of the 7 or the 2 because it's not a common factor. We can't easily get rid of it. So it's complex by definition. Now, me personally, I prefer to teach using a different method called decomposition. So many of you who have tutors or might have learned from different people regarding this concept might have learned different methods. That's completely fine. If your method works, your method works. I prefer to teach decomposition, so that's what this lesson's all about. Okay? This method involves breaking up that middle term into two separate pieces. So the middle term, again, being that term that's attached to x. Okay, so whatever that number is. And then factoring it by grouping to obtain that common bracket. So the only difference actually between this and our simple trinomials game now, though, is that the product number is actually going to be the product of this first term's coefficient and this very last constant, okay? So our product game is kind of changed. Our multiplies 2 is kind of changed. Our sum is still the same. So the number in the middle is the one that we're trying to get the sum of, okay? So the number in the middle is still essentially the same idea. Okay, so here are two examples. I'm going to walk you through these two examples personally, and then I'll give you two examples to go ahead and pause and do, okay? So for this first example, we're given a lead coefficient of 2. Now the reason why we decide to do complex trinomial factoring is that we can't factor the 2 out of those other two terms, right? We can't divide the 13 by 2, and we can't divide the 15 by 2. So we cannot common factor the 2 out. Once we've determined that, our adds 2 number is still the same. It's still that number that's in the middle, and our multiplies 2 number is slightly different, okay? It's actually going to be 2 multiplied by 15, and 2 times 15 is 30, all right? So our multiplies 2 number is a bit different, okay? So take a moment, think about those two numbers. Oh yeah, 13, 30, you've been doing simple trinomials so much that you know your numbers are actually 10 and 3, right? But what do you do with those two numbers is also slightly different when we're doing decomposition. Remember that I said in the first slide there that we're going to break down this middle term into two pieces. One piece that is 10x and the other piece that is 3x. And again, they're both positive, so I put pluses in front of both of them. The first term remains 2x squared, and the second term, the last term, remains 15. You'll notice again now that I have 4 terms, and if you'll actually go back and watch the common factoring video, I did mention a method called factoring by grouping. So now we're actually going to do factoring by grouping. So this will be a little bit of a friendly reminder of how to do that. When you have a term that's got 4 terms, you're going to look at the first 2 terms, and you're going to ask yourself, what can I common factor out of both of those? Well, we can common factor a 2 out of both of those, because 10 is divisible by 2. We can also common factor an x out of both of them, because of the x squared term and because of the x term there. When we take the 2x away from those first 2 terms, we're left with just 1x and a 5. Okay? So that's what we're left with in that first set of brackets. In the second set of brackets, we're also going to group those. Well, what can we common factor out of both of those? I can common factor a positive 3 out of both of them. And if I common factor that positive 3, I'm also left with, surprise, surprise, x plus 5. So if you remember common factoring or factoring by grouping, you'll also remember that this guy and this guy have to be the same. And if they're both the same, I can common factor that out and then just write my leftovers of 2x plus 3. And that is how you factor a complex trinomial. So you'll notice that a complex trinomial's coefficient right here is going to wind up popping up. So at the very beginning, the coefficient was 2. Down here, that's where the 2 came from. Okay, so they match up nicely that way. So really, the only extra step here is decomposing that middle term, decomposition of that middle term. Okay, so your second example, almost identical. Okay, so again, we have this first term of 18 that cannot be factored out. Okay, so we do decomposition. We're looking for an adds 2 number of negative 7 and a multiplies 2 number of 18 times negative 1. 18 times negative 1 is negative 18. So we got to ask ourselves, what are our two numbers? Well, if it multiplies to negative 18, that means that the two signs are different. Okay, so remember, a little bit more difficult, but if you think about it for a little while, you'll realize that the numbers are negative 9 and positive 2. What do we do with those two numbers? We're going to break down or decompose that middle term into those two pieces. So basically what we're doing again is rigging a factoring by grouping question. Okay, we are rigging that factoring by grouping question by breaking down or decomposing that middle term into two pieces. So again, what I'm writing here is still equal to what's above. We've just broken that middle piece into two. We then do factoring by grouping. So now we have four terms. This should be nothing new, right? Out of the 18x squared and the minus 9x, we can take out a 9x, and we can be left with 2x minus 1. In the second set of brackets, oh look, we already had 2x minus 1. So what can we factor out of that to make it the same? Well, all we have to do is just factor a positive 1 out of it, and it stays the same, right? So our very last step is to just notice that 2x minus 1 and 2x minus 1 were common factors. We can factor that out. And our leftovers are 9x plus 1. And that is equal to what's above. So again, you'll see that the coefficients of 2 and 9, 2 times 9, was the 18 up top there. That's where it comes from. Okay? Give these two examples a try. So the first one, 3x squared minus 7xy plus 2y squared. And the D example, see if you can common factor first with question D. You'll remember as well, though, my little note at the bottom, that decomposition is a method that can be used to factor simple trinomials as well. It's just not all that efficient. So if you want to as well, while your video is paused, I want you to factor that very simple trinomial on the bottom using decomposition, and I'll scroll down and show you that in just a moment. Alright, so here are the solutions for questions C and D, and I'll scroll down and show you the decomposition solution as I highlight through the answers here. So my first point of call was the adds 2 and multiplies 2 of negative 7 and positive 6. The two numbers that I determined were negative 6 and negative 1. I used those two pieces of info to decompose negative 7xy. You'll notice that in this example, okay, my variable is xy, and so my variable remains xy here. We're kind of doing the opposite of collecting like terms. Then we basically just take over and do our factoring by grouping, so that's what happened here and here. So we factored basically the 3x out of the first two terms and just a minus y out of the second two terms. What I highlighted in red at the bottom is the x minus 2y, and the leftovers are underlined in purple there. In question D, you'll remember I hinted that a common factor needed to be taken out first, and the 6, the 20, and the 16 suggest we could take out a 2, but they also suggest, because of the exponents here, 3, 2, and the power of 1, that we could actually also take out an x. Okay, so once you've taken out that 2x, you're left with, on the inside of those brackets, a complex trinomial anyway. So you attack that complex trinomial just as you would examples A, B, and C. Our adds 2 and multiplies 2 game is slightly different because we did that common factor. Right? So it's going to add to negative 10, it's going to multiply to 24. Our numbers are negative 6 and negative 4. Once we've done that decomposition in here, there are the two terms that we've decomposed into. We do our factoring by grouping. So over here underlined in green and in purple are our two possibilities. So there they are in green and in purple. You'll notice again that we get an x minus 2 and an x minus 2, so that gets factored out and underlined in blue. Okay, so our final answer is actually going to be three different factors: 2x, x minus 2, and 3x plus 4. Our final example, just again to show you that you could have decomposed that instead of just factoring a simple trinomial. Your adds 2 and multiplies 2 game is basically going to be negative 5, which is the number that's in here. The multiplies 2 negative 14 is actually 1 multiplied by negative 14, which is negative 14. Your two numbers are negative 7 and 2. So if you chose to decompose, you would get negative 7 and positive 2 for the decomposition of that term, the middle term. And then if you factored by grouping, you'd wind up getting x minus 7 and x plus 2. But if you remember anything about factoring by decomposition, you will remember that this little guy here should easily lead to your final answer anyway, because it was a minus 7 and a positive 2, right? So again, decomposition, great useful method for complex trinomials, not so much for simple trinomials. It's a bit of a time waster if you're going to go for simple trinomials. So I hope those examples were sufficient for you. I want you to consider that again. If that was really fast for you, please watch the video a second time, watch the video a third time. Okay, come to class tomorrow, ready to do some more examples of complex trinomials.